Hello, welcome to SQL Server to Azure Synapse code conversion overview video. My name is Andrei Mirsky and I work in Appliance Migration Accelerator team at Microsoft. Our team helps customers to migrate and modernize their data warehouse solutions in Microsoft Azure Cloud. This video is part of a larger series of training videos on SQL Server to Azure Synapse Migration Toolkit. This toolkit was developed by my colleague Dr. Gail Zhou, and it is publicly available at GitHub in Azure Synapse Scripts and Accelerators repository, which you can see on my screen. So let's get started. As we are discussing migration from SQL Server to Azure Synapse Analytics, let's go to Migration folder and SQL Server subfolder. Migrating any data warehouse solution includes migrating table definitions, tables data, and the code of data warehouse. In case of SQL Server, by the code, we assume views, functions, and stored procedures. Migrating table definitions and data migration is pretty well covered by Gail in her other videos. And I will focus on migrating the code only. This will include views, functions, and stored procedures. Okay, before actually running a SQL Server code migration, let's briefly take a look at the demo environment. Yes, as we are talking about migrating of SQL Server, yes, I have my own SQL Server instance. It is SQL Server 2019, however, migration scripts should transparently support any SQL Server version starting 2005. There are 4 databases here. These are sample Microsoft sample databases: AdventureWorks 2019, AdventureWorks DW or Data Warehouse 2019, Wide World Importers, and Wide World Importers DW or Data Warehouse. You can find and install exactly the same databases in your own environment. Simply download backups of these databases. These backups are available at GitHub, publicly available repositories. Here are the links. So if you follow the links, you will find web pages. This is for AdventureWorks sample databases. So you can download full database backup for OLTP and Data Warehouse databases. The same for Wide World Importers database. So this is another web page at GitHub, and here you can download full backup for Wide World Importers and Wide World Importers DW databases. So you can have exactly the same databases and you can follow the same steps, which I will be demoing. Let's briefly explore these databases. AdventureWorks DW 2019 databases. Here we have some tables, some dimension tables, some fact tables. There are few functions, scalar valued functions, and there is no stored procedure. Another database, which is Wide World Importers DW. Of course, there are some tables, again, some dimension tables, some fact tables. There are some integration tables for data loading. There is no view here. There are some stored procedures. And there is only one table valued function. Of course, I have also my own Azure Synapse Analytics workspace and a dedicated SQL pool called EDW or Enterprise Data Warehouse. I will be migrating my SQL Server databases code from the databases which we discussed previously into this EDW dedicated SQL pool. So we are ready for actual SQL Server databases code conversion. Getting back to GitHub repository. So first I need to download the whole code for the GitHub code repository and have it locally, because I will be running code conversion in my demo environment. I already have it on my C drive, Azure Synapse Scripts and Accelerators. It's here. I go to Migration and SQL Server folder. And the idea is very simple. To migrate the code, first we need to extract DDL scripts for every object which we are going to migrate. And then we need to convert extracted DDL scripts and make it Azure Synapse compatible. So for this purpose, we have module 1A, extract code DDLs, and module 1B, map databases and schemas. So first, let's start with module 1A, extract code DDLs. This module is implemented as well as other modules as a PowerShell script, extract code DDLs, PowerShell script. This script uses two configuration files. First is extract code DDLs _ config. This is JSON file. Let's take a look at the content. Here we specify connectivity information, essentially server name. This can be a default instance or it can be named instance. You can use whatever naming like this, or IP address, whatever allows you to connect to your source SQL Server instance. There is a flag integrated security, yes or no. So either we use Windows integrated authentication or we will use SQL Server authentication. I will be using SQL Server authentication. And there is output folder. This is the folder where extracted DDL scripts will be stored. Note that both absolute and relative paths are supported. And because this is JSON file, slashes should be doubled. The other configuration file called databases list. This is simple CSV file which includes the list of SQL Server source databases which will be migrated, or code objects from these databases will be migrated. Here we have flag active, which can be 1 or 0, which means that we're going to migrate or not migrate objects from corresponding database. We have 4 databases in my demo environment, and we will be migrating code objects for all databases. So I have 4 records here. Here, everything is configured to connect to my demo SQL Server instance and extract DDL scripts from sample databases. So let's run the script. I have PowerShell window open here. So let me simply run PowerShell script extract code DDLs.ps1. The script prompts for configuration file names. First is databases list.csv. Yes, I use default. JSON configuration file. Yes, I use default configuration file name. And the script prompts for SQL Server credentials because I configured to use SQL authentication. I enter configure credential information, and the script extracts DDL scripts from SQL Server databases, sample databases, and stores in output folder. Just a few seconds and everything is done. Let's go to Windows Explorer, level up, output folder. We have subfolder 1A _ extract code DDLs. This path was configured in my JSON configuration file. Under this folder, we can find folders, 1 folder per database. And under every folder, we see subfolders based on object type. So in AdventureWorks DW 2019 database, there are functions and views. So we have functions and views folders. And under views folder, we can see several files, and every file contains a script for corresponding view. For instance, this one, dbo.vdmprep. And we can see the contents of this script. So this is DDL script create view as is, without any changes. Note that all formatting is preserved, so you get the same formatting as you would get it in SQL Server Management Studio by generating a script for this object. So this is the result of executing module 1a extract code DDLs. We have all DDL scripts for code objects extracted from sample databases. Now, when we have extracted DDL scripts, we need to prepare these scripts for Azure Synapse environment. And the key thing to consider here is that we may need to map source schemas to target schemas. Remember, we have multiple source databases in SQL Server, like AdventureWorks, Wide World Importers, etc. However, we have only one database in Azure Synapse Analytics Workspace, because cross-database queries are not supported, at least as of now. So imagine a situation. We have database 1 and database 2, and both databases have the same table, like dbo.dim_account. So when consolidating these two databases into a single database, we will have a naming conflict. We have two tables which have the same name in the same schema. To avoid such object naming conflicts, there is a common approach, which is to replace source schemas to target schemas. This should be done in all code objects. This includes views, functions, and storage procedures. Hence, this may require a lot of manual efforts. To accelerate and simplify the process, we have module 1b, which is map databases and schemas, which performs this replacement at scale. So getting back to code repository, SQL Server folder, and we have module 1b, map databases and schemas. Apart from this schema replacement, this module can also perform the following actions. First, it can add default schema name to object references where schema name is missing. This will help to replace schema names in case when schema name is missing. Otherwise, schema replacement would not be possible. Second, it can replace all two-part names to three-part names. This change might be available in case of cross-database queries capability when this capability is added to Azure Synapse Analytics. And third, it can identify if any unsupported data types are used in functions and storage procedures. It can be found in parameters, variables, temporary tables, or data type casts. This module is also implemented as a PowerShell script. The name of the script is map databases and schemas.ps1, and it uses two configuration files. Schemas. Schemas is the CSV file which defines schema mapping approach. Look, for every source schema in a source database, we define a schema in a target database, which is Azure Synapse dedicated SQL pool. So, for instance, AdventureWorks DW database, DBO schema is to be mapped to EDW database ADW schema. And Wide World Importers DW source database, DBO schema, will be mapped to EDW dedicated SQL pool and schema name is wwidw. So if by any chance we have, for instance, a table with the same name in DBO schema in two databases, AdventureWorks DW and Wide World Importers DW, these two tables will be migrated to two different schemas, ADW and WWIDW. Hence, we avoid naming conflict. The other configuration file is cs_dirs or directories. This is also a CSV file which for every database defines source and target directories or folders where source DDL scripts are stored and where converted DDL scripts will be stored. For instance, for AdventureWorks DW database, we have this source folder for functions and this target folder for functions DDL scripts which will be converted. And also we identify that, hey, this record defines source and target folders for functions. Same for storage procedures and views. Please note that both absolute and relative folder paths are supported here. Here, everything is already configured for my demo databases, so I simply run the script. Go back to Windows PowerShell window, change directory, go to module 1b and execute the script. I confirm default configuration file names. Now the script prompts if I would like to use three-part names in converted DDL scripts. I confirm default value, which is yes. The script also asks if I would like to add missing schema names to object references, and I confirm default value, which is yes. And now the script is running. It will take just a few seconds for my demo environment. Of course, it depends on the amount of code you have in your own environment. I mean, the number of storage procedures, views, and functions, the size of those objects, because the bigger storage procedure, the more time is required to convert storage procedure DDL. So now it's completed. Please note that we have summary here, total files analyzed 121. So in total, 121 objects were analyzed. There were found 4 files or 4 objects where unsupported data types were found, and there are 7 total occurrences of unsupported data types. And you have summary how many occurrences for every unsupported data type were found. For instance, for hierarchy ID, there was only one occurrence, only one object. There are 4 occurrences of text data type and 2 occurrences for geography data type. And let's switch to Windows Explorer and folder level up and output folder. We have one BMap databases and schemas folder. And here we have, again, in similar structure as previously, we have converted DDL scripts for our demo databases. Let's examine one of the converted storage procedures. So let's open AdventureWorks 2019 folder stored procedure folder and this stored procedure. First, we can see that object references now include database name. So in other words, it is 3 part names. Second, we can see that schema names were replaced according to schema mapping, which we defined previously in configuration CSV file. So human resources schema was replaced by AW_human resources. And finally, you will not miss it, of course, you can see unsupported data types warning at the very beginning of the script. It provides information regarding every unsupported data type and specific lines in code where it was found. In this case, hierarchy ID was found once and at line number 4. Well, line numbers are counted as per original script before any modifications. So it's not this line number 4, it is line number 4, assuming that the script was started somewhere here. So here is line number 4, and we can see that organization node parameter is defined as hierarchy ID data type. Good stuff. However, it is worth mentioning that these are all possible changes which are currently supported. There are multiple features which are not yet supported in this conversion. This includes triggers, cursors, common table expressions, user-defined data types, and many others. Of course, you can find unsupported features in the documentation. Okay, now when we have converted scripts for views, functions, and stored procedures, perhaps after some manual changes, we are ready to run these scripts at Azure Synapse dedicated SQL pool to create converted objects. And for this purpose, we can use module 5, which is run SQL files in a folder. This module allows to easily execute multiple SQL scripts stored in a single folder. This module is covered by Gail in the other video. Remember, all module details are pretty well covered in the documentation, which is available in GitHub repository. So when you open the respective folder, you can find detailed description for configuration file format and the details of the module logic. This concludes this demo, and I hope you enjoy it.